Yeah, it's going to be a short one, hopefully. We're going to talk about solving systems of equations by using substitution.
Oh, dang it.
Guys, this is my lecture starting. So we're gonna be talking about solving systems of equations. Remember last Friday we talked about this briefly, and I told you there were 3 ways to solve systems of equations, right? 3 ways. There's 3 ways. We said the first one was by graphing, and you guys already know how to do that, right? We just did that on the quiz today. The second way is through substitution.
3 ways.
Yes. And the third way, the second way is what we're going to talk about today. The third way we will not talk about today. It's called elimination. Okay? But this is what we're going to work on today, substitution. Now, it's also important to understand, because you're going to see them called different things at different times. Their systems of equations are also called simultaneous equations. I actually like that term a lot better than the systems of equations, but I use systems of equations because 90% of the textbooks use systems of equations or linear systems when they talk about these. They rarely use the word simultaneous equations. Saxon uses simultaneous equations, but most other texts don't. There are exceptions, obviously, but I actually like the term simultaneous because it makes sense. I've got 2 equations simultaneously on the same graph, and I'm just looking for where they cross, right? Whereas systems of equations, it doesn't really make, I mean, you have to think of a stereo system. Okay, there's lots of things. Like there's more than one thing, so there's two lines, or maybe 3 lines, or whatever. So, but whatever. And then linear systems, when you see linear in math, it always means straight line, right? It never means a circle line. I mean a curved line, a parabola. Linear means straight line, always. Okay? So when they say linear systems, we're talking about 2 straight lines, or 3 straight lines, or 4 straight lines, and where do they all meet, right? So that's what we're talking about. So there is this really cool method. We learned by doing graphing. So far, it's always worked. I've been nice to you. But sometimes the lines don't cross right on a corner. Instead they cross right like in the middle or somewhere over here. And there are like, I mean, who the heck knows what point that is, right? I mean, there are an infinite number of possibilities. You know, it could be 1, 2, 3, 4, 5, 6, 7, 8. 8 and 2/3. It could be 8 and 3/4. It could be 8 and 7, 15ths. It could be 8 and 21 43rds. I mean, who knows, right? And so you could be doing it for years, the same problem for years before you found the right answer, right? So that's why we also have other methods to do it algebraically, not just with a picture, not just with a graph, but algebraically. And that's what substitution is all about. I moved all my books somewhere. Does anybody know where I put them? Okay, great intro to them. Okay. At least my lectures are humorous, right? When you go back and watch them. Yeah. Okay. So I'm just gonna take one right out of the book. 2x. So it says solve this. 2x. Where am I? Minus y is equal to 1, and then x equals negative 3y plus 11. All right. What does substitution mean? Sal. Replacing something with something else. That's exactly what we're going to do. Okay? So, since we are looking for where the 2 equations actually touch, we're looking at a place where the y's of both equations are exactly the same thing, right? And we're looking for a place where the x's of both equations are exactly the same thing. Therefore, I want to look for something that says either y equals or x equals. Which equation says x equals? The second one. Look, that tells me that x is exactly the same thing as this. And I know that since I'm looking for where x's are exactly the same in both equations, I know that wherever I see an x in the other equation, instead of having an x there,
You do negative.
I could replace it with this. Does that make sense?
Yeah. Oh!
Does that make sense? So if x is the same thing as this, then I could replace this x
With that.
with that, right? And why would that be helpful to me? Yes.
Then you're eliminating one of the variables.
Yeah, instead of having two variables, suddenly I'm only going to have y's. And if I have one equation with one variable, I can always solve for that variable, always. But if I have one equation with two variables, I can never solve for that equation. I mean, for those variables. But if I have two variables with two equations like this, I can, because I'm going to substitute what x is equal to into the first equation. Sometimes it's the second equation. Sometimes the x equals is in the first equation, and I substitute what it is into the second. But whatever. So now we're going to just substitute that in there. We're going to have 2. Now I got to use a parenthesis because I'm going to put this in there, right? Times negative 3y plus 11, parenthesis. Now it says minus y. Minus y equals 1. This is cool. That just made this problem so easy. I'm going to be able to find y really fast. So I'm going to use my distributive property. So I've got negative 6y plus 22 minus y is equal to 1. Now I'm going to look for common like terms, right? So I've got negative 6y and a negative 1y. How many y's do I have? Right? Negative 7y's, right? See that? They're all on the same side of the equal sign. I'm not gonna do this. This is what a lot of people do that is wrong. They will go like this. Plus y, plus y. What's wrong with that?
It's on the same.
It's on the same side of the equal sign. Then you think you're doing it on both sides. Well, you're not. You're doing two. You're adding two y's out of nowhere to the left side and not anything to the right side of the equal sign. So that isn't
So
what
that
you
would
do.
become like 2y.
Right. So that's not what you do. These are all both on the same side of the equal sign, so I can just combine them. I've got negative 6y plus negative 1y, that's negative 7y. Negative 7y plus 22 equals 1. So now, what would I do? I want my y's all by themselves. So let's get rid of the 22. Subtract 22. Subtract 22. And that gives me negative 7y is equal to negative 21. Ooh, that's cool. So now,
And then could you
yeah. So how would I solve for y now?
You divide it by 7.
You lift y.
So divide both sides by negative 7, then I'll get 1y, right? Divide by negative 7. Divide by negative 7. And then y is equal to,
3.
is it positive 3 or negative 3?
Positive.
How many people think it's positive 3? Raise your hand. How many people think it's negative 3?
Oh, I think it's positive. Sorry.
Okay. It is positive. It's positive. So it's 3. Great. So we now know that they cross at y is equal to 3. What do we not know?
X.
Where x is.
And then could you plug that into the x equation where it says y?
Yeah, and what method are you using for that? Substitution again. You're substituting. We now know that y for both of these is 3, right? Now, which one, I can substitute it in for either one to find my x. Well, which one would be easier? Which one? This one or this one?
No, but if that happens,
Well, maybe. Usually, because this already says x equals, it already said x equals. If I just substitute y into this, then I'll have my x equals, right? But I mean, I could do, that's pretty easy too. But I'm going to just substitute in this one, because this will tell me what x equals. X is equal to negative 3 times 3, right? Y is 3, y is 3, plus 11. So x is equal to negative 9 plus 11. X is equal to 2. Right? Am I right? Did I do it wrong? So my answer, I could either go like this. I could either circle that, or I could say the solution is 2 comma 3. Right? Either one, either way. Does that make sense?
Yeah.
And all you're doing, this is the key. One of them has to say x equals or y equals. As long as you have one of them saying x equals or y equals, then you've got it. Now what if, I'm going to come over here for a second. In fact, I'm going to use a different color because I don't want, let's say I gave you 2 equations and I said 2x plus y equals 4 and x minus 2y equals 10. Let's say those were the problems. We're not going to do this. But none of them say x equals or y equals. But could you make one of them say x equals or y equals? Or Micah?
Minus 10 from both sides and then subtract x from both sides. So it'd be like negative 2 minus 2y equals negative.
Yeah, but you're making it harder than you have to. Because that would be negative x. I want it to say x. Right? So, what's in the way of x being all by itself? This, right? Let's just add 2y to both sides. Right? So if I added 2y to both sides, then I would have x is equal to 2y plus 10. And now I have it. And so I could substitute that in for the other equation, the x, right? 2 times 2y plus 10, parentheses, plus y equals 4. Make sense? Justify. You guys get it? So that's what the assignment is. That's what the chapter is today. The lesson for tonight. It's really an important lesson. So do it well. Really be sure you get those.
Wait, how did you
Make sure you read it. I really recommend you read it well tonight. Because this is something you will see a lot in algebra.
It is 10 alpha.
Make sense, Dick?